Welcome to my class of science. Specifically today we are looking at chemical formula and equation. That is our topic, our main topic. Then out of those two headlines, we are going to look at chemical equation today because last time, those who are following me, we were looking at chemical formula, of which we did successfully. So now let us see how we are going to fare on chemical equation. Okay. So the first point there, a chemical equation shows the chemical formula of reactants and products in a reaction. Okay. So now you must understand what a reactant is as well as the product. What do I mean? I'm trying to say that you should differentiate these two. Okay. So the reactant, when you are talking about reactants, we are talking about the elements, either elements, compounds, or molecules that are involved in the reaction. Okay. So the first, for example, if we get hydrogen and oxygen, when hydrogen and oxygen reacts, so as they are reacting there, collectively we call them reactants because they are reacting. Okay. Then whatever the result is going to be produced is what is called the product. Okay. So now what differentiates that? What differentiates that is the UD arrows. There is always an arrow there. Okay, which that differentiates between the reactant and the product. So point two, it consists of the chemical formula of reactants and products, unit arrow, state symbols, and coefficients. So those are the things that are involved in the chemical equation. So you would find, as I was saying, you are going to find the chemical formula there. Okay, so chemical formula, it could be just an element. For example, or hydrogen is represented by letter H. Okay, so that is the chemical formula. So you are going to find that. Then apart from that, we also find the reactants and the products. Then use arrows, the arrow that shows how the reaction is flowing. Okay. Then state symbols. State symbols now, these are just the symbols that shows the state in which a given element, a given compound molecule is. Okay, in which state? So that is the state symbols. They will always be the state symbols. Then and the coefficients. Coefficient, even in mathematics, we are very much aware of that. This is not the first time you are hearing about this word, coefficient. So coefficient, this is actually a number. Okay. For example, if you have 2x, so that 2 is a coefficient and x is the variable. Okay, so coefficient also is always what? There in the chemical equation. You should know that. Then let's talk about UD arrows now. Point 3. UD arrows, this is the symbol for UD arrows. Separates reactants and products. As I said in my first place, I mentioned that. So this is UD arrow which separates the reactants and the products. Okay. Then it shows the direction of the reaction, how the reaction is flowing, the direction. So now we have a full stop there. A reversible reactant that goes forward and backward is shown by a double arrow. So when you have a double arrow, just know that this reaction has gone this side up to the product and it has reversed, it has gone back. Okay, so we are going to have two huge arrows. Okay, I like the way they have indicated it in symbol form. Then point 4, state symbols are written as, so now let's talk about the state symbols written as S representing solid, L representing liquid, and G representing gas for solid, liquid, and gas respectively. Okay. Then substance dissolved in water. Another term, aqueous solution. So there are some substance that dissolve in water, and we call those substance. When they make that solution, when they dissolve, we call that aqueous solution or miscible solution. Okay. So aqueous solution is also one of the what? The state symbol. Okay. For example, we have the other term, aqueous solution, are represented by the AQ, just AQ. That is aqueous solution. It's also a state symbol. So in a chemical equation, in a chemical equation, it's very, very important to actually understand the state symbols because they are always needed. Okay. Then point 5. A coefficient is a number in front of the chemical formula, just like I was explaining. So that's a coefficient. So it shows the number of molecules of the substance that are involved in the reaction. Okay. The number of molecules or atoms that are involved in the reaction. So that one is shown by what? A coefficient. So if you have one coefficient, just know that this is one molecule. If you have two coefficients, that is two molecules or two atoms. Okay. So point 6, for example, hydrogen and oxygen react to form water. So hydrogen and oxygen react to form water, and that is true. When hydrogen and oxygen reacts, they form water. This reaction can be written as, a chemical equation as shown below. So this is the one we are talking about. So 2H2, we have the state symbol there. 2 is the coefficient, then 2 molecules of hydrogen gas. Then G is state symbol, which is gas, plus hydrogen or oxygen 2. Then we have gas again, G represented, the state symbol there is gas. Then huge arrow. Then from there now the products. This is the reactant. Now product. Now we are going to have chemical formula like 2H2O. It is in the form of what? Liquid. That is the state symbol. So that is it, liquid. Okay. Then let us now look at the steps that one can take in order to come up with the chemical equations. So balancing chemical equations. So first of all, we want to look at the balancing of chemical equations. So what are some of the steps you are supposed to take as a candidate, as a learner, for you to balance a chemical equation appropriately? So the first point is atoms. Atoms cannot be created or destroyed. So the number of atoms in reactants must be equal to the number of atoms in products. So as you may be aware, atoms cannot be created. That is point 1. Then atom cannot also be destroyed. Therefore, the number of atoms that are found in the reactant should tally or should be equal to the number of atoms that are found in what? In a product. So that simply means the atoms, no matter, or I may use the word, the type of reaction that particular elements undergone, atoms will still remain the same. They are unchanged. Okay. So that's why it's important to make sure that the number of atoms in the reactant balance with the number of atoms in the product. Okay, that is point number 1. You must know that. Then point 2, the following are steps involved in balancing a chemical equation. So let us soon see the step that you can take for you to balance the chemical equation. One of them is write the unbalanced equation. So the first thing, just write the unbalanced equation there. Then 2, write down the number of atoms used and produced for each element. Just write now the number of atoms used and produced in each element. Then 3, find the coefficient to balance now the equation, dealing with one atom at a time. So now when you are looking for a number that can balance now the equation, you have to find the number of atoms now. And you have to make sure that as you are balancing, that should be done one at a time. Okay, to each atom. This one, you get a number so that you balance the reactant and the product. Okay. Then the last point, in fact, we are on 3. Find the coefficient to balance the equation, dealing with one atom at a time. Usually, it is good to start with the most complex compound. So, for example, in that chemical equation, if you have the most complex compound, start with it. It's very, very important. It really helps. Okay. Then 4, reduce the coefficient if necessary. So there are situations whereby here you have 4, the other side you also have 2. There you can reduce because you have 2, which is the common number. Okay, that can go into 4 and 2. So we can reduce if necessary. So if they say if necessary, that is a condition, simply means it depends on the chemical equation that you are trying to balance. Okay, so for now, we are going to end there, okay, for this lesson. But you should know that in our next lesson, we are going to look at now examples. Okay, how can we balance the equation? So kindly subscribe to my YouTube channels for more lessons under this, so that you can actually understand fully. Okay, thank you so very much for now.